See Lindelof videos. Find the inverse function and its domain and range. We're going to use a trig function today. So we have f of x is equal to 5 sine x plus 2. So this looks actually initially like regular algebra, so I'm just going to rewrite f of x as y. I'm going to recopy this sine x plus 2. Going to interchange, that is to switch, interchange x and y. So here we had x, so I'm going to take that x out, put that x here. Here we had y, so I'll put the y here. So I've interchanged them, I've switched their positions. I'm going to go now and start solve. I'm going to go ahead and solve for sine y. Remember I had a 5 here, sorry about that. So there's that 5. So what I'm going to do is add negative 2 to both sides, so you get x minus 2 is equal to 5 sine y. Going to divide both sides by 5. We'll get x minus 2 divided by 5 is equal to sine y. Remember that y is the argument. It's not sine times y, so we can't do any division there. This is called the argument, and sine is the operator, so we're stuck with that. We can't do anything really with this, except for we can use our definition. So we can use the definition of inverse sine x, which also allows us to make this statement that y is equal to the inverse sine, I was going to say x, but we have an argument, and it's x minus 2 over 5. Your professor will be looking for you to use this definition, and he or she probably will not ask you to prove that, so I'm just going to go with that. So here is my inverse function. The only thing I am going to do is I'm going to clean this up a little bit, because it's not truly y, it's the inverse of f of x is equal to sine, the inverse sine of x minus 2 over 5 is how your professor will probably want to hear that. Now what we're asked to do is we're asked to find the range, and we're asked to find the domain here. It's actually pretty straightforward, and I'm going to go to the original equation. The original equation said that we had y is equal to 5 sine x plus 2. So all I'm going to do here to find this, I'm going to solve for sine x. I'm going to try to solve for sine x. So that gives us y minus 2 is equal to 5 sine x. And I'm going to divide by 5. So if I divide by 5, it looks like that, doesn't it? And this might seem kind of weird to you, like, okay, what am I going to do with this? Well, if you remember that the range of the function becomes the domain of the inverse function. So I'm just going to use this. This is the function. I'm going to find its range, and I'm going to call that the domain of the inverse. So we know if you look at a normal sine curve, a normal sine curve has a range from negative 1 to 1. If you kind of look at that in your head, you can see that the curve on sine x, its lowest point is at negative 1, its highest point is at 1, and it hits continuous, so it hits every place in between. But what we know here is that our sine of x is y minus 2 over 5. So I'm going to put that in. Y minus 2 over 5. To get rid of this 5, I'm going to multiply everything by 5. We'll get negative 5 is less than or equal to y minus 2, which is less than or equal to 5, right? From here, I have to add 2 everywhere to get rid of this negative 2. That takes us to negative 3 is less than or equal to y. Y is less than or equal to, remember I added 2 here, so this would be to 7, wouldn't it? Sure would, to 7. Well, this is range of f. But because we have an inverse, it becomes the domain of the inverse x. So the domain here is not y, but x. X such that x is greater than or equal to negative 3, but less than or equal to 7. All right? And of course, I think that we know the range of this, and hopefully you have this memorized, that the range here will be from negative pi halves to pi halves. Otherwise, those sign values start to repeat. All right, I hope this was really helpful. This is not super difficult, but you do have to have a strategy. If you have any questions or comments, please let me know. If you haven't already subscribed, please do.